Today we're diving into the world of GPUs, those magical chips that make our games look amazing, but there's so much more to them than just gaming. But what exactly is a GPU? How does it work, and why is it so important for modern computing? In simple terms, a GPU or graphics processing unit is like a second brain for your computer, specifically designed to handle visuals. It's a specialized processor that accelerates the rendering of images, animations, and video. Imagine your CPU as the main brain, taking care of all the general tasks like running your operating system and applications. It's versatile but not specialized. The GPU comes in as the visual specialist, taking over the heavy lifting when it comes to displaying images, videos, and of course running your favorite games. It's optimized for parallel processing, which means it can handle thousands of tasks simultaneously. Without a GPU, your computer would struggle to display complex graphics. And forget about playing the latest AAA titles. Even simple tasks like watching a high-definition video would be taxing. GPUs are designed to process tons of visual information simultaneously, making them essential for anything from watching high-definition movies to running complex 3D simulations. They're also crucial in fields like artificial intelligence, scientific research, and even cryptocurrency mining. So, next time you're enjoying the stunning visuals of a game or marveling at a high-resolution image, you'll know that your trusty GPU is hard at work behind the scenes, making it all happen. Whether it's for gaming, professional work, or scientific research, GPUs are indispensable in our digital world. Alright, now that we know what a GPU is, let's break down how it actually processes graphics. This is a fascinating journey into the heart of what makes our digital worlds come to life. Think of your screen as a giant grid of tiny squares called pixels. Each of these pixels is a building block of the images and videos you see on your screen. Each pixel needs to be told what color and brightness to display to create the images you see. This process happens so quickly and seamlessly that we often take it for granted. This is where the GPU comes in. The GPU, or graphics processing unit, is the powerhouse behind this intricate process. It takes data from the CPU, which is like the director of the show, and figures out what needs to be done with each pixel on your screen. The CPU sends instructions, and the GPU executes them with precision. It's like having a team of artists working tirelessly to paint each individual pixel with the correct color and shade. Imagine an army of painters, each assigned to a specific part of the canvas, working in perfect harmony. But here's the thing, modern games and applications demand millions, even billions of pixels to be rendered simultaneously. This is a monumental task that requires immense computational power. That's a crazy amount of information to process. The sheer volume of data is staggering, and it all needs to be handled in real time to ensure smooth and immersive experiences. Luckily, GPUs are designed specifically for this kind of workload. Their architecture is optimized to handle vast amounts of pixel data efficiently. They have thousands of tiny processing cores that work in parallel, kind of like having a massive team of artists working on different parts of the image at the same time. This parallel processing capability is what makes GPUs so powerful. This allows them to handle the massive amounts of data required for realistic graphics with incredible speed and efficiency. The result is stunning visuals that bring digital worlds to life, making our gaming and visual experiences more immersive than ever before. Now let's talk about parallel processing, because that's where GPUs really shine. It's a fascinating concept that has revolutionized the way we handle complex computations and tasks. Imagine trying to build a house all by yourself. It would take forever, right? You'd have to lay every brick, install every window, and paint every wall on your own. But what if you had a whole team of builders working on different parts of the house simultaneously? One person could be laying bricks, another installing windows, and someone else painting the walls. The house would be built much faster and more efficiently. That's the basic idea behind parallel processing, breaking down a big task into smaller tasks that can be done at the same time. Instead of one person doing everything, multiple people work on different parts simultaneously. CPUs are like really good solo builders. They can handle complex tasks, but one at a time. They are excellent at sequential processing, where tasks are completed one after another. GPUs, on the other hand, are like having a massive construction crew. They can handle many tasks at once, making them perfect for parallel processing. They have thousands of cores that can work on thousands of tasks simultaneously. Each core can handle a small part of a larger task, allowing for incredible speed and efficiency. This makes them incredibly efficient at handling tasks that can be broken down into smaller, independent chunks, like processing all those pixels we talked about earlier. Each pixel can be processed by a different core at the same time. This parallel processing power is what gives GPUs their edge, not just in graphics but also in other fields like scientific computing and AI. They can handle massive datasets and complex algorithms much faster than CPUs. We'll explore these applications in more detail later.